In previous lectures, we have covered the basic concepts of the philosophy of nature, matter and form, nature and causality, motion, place and time, and the continuum. Now we must move to the most difficult part of the discipline, namely, that concerned with the proof for the existence of a first unmoved mover. What we shall say about this presumes that you've mastered all of the material treated thus far, that you understand it to the point where you can put the concepts we have explained to practical use. This is not a very realistic expectation. Our situation is similar to that of a teacher who has explained to the class a few ideas behind the calculus and then expects the students to solve problems with its use. On the other hand, even at this stage, you may not be able to grasp the full force of the proof. You probably will appreciate obtaining an overview of the arguments on which it is based. And that is the most we can reasonably expect from this lecture. I hope mainly to lay the groundwork on which you can build in your later studies and perhaps throughout your life. As in previous lectures, we will be tracing the main outlines of Aristotle's thought as found in his Physics, now mainly from books 7 and 8. But we shall also be getting help from St. Thomas Aquinas, more than in earlier lectures. We shall make use of Aquinas' commentary on these books, as well as in his theological writings. Aquinas' Prima Via. St. Thomas's proofs for the existence of God, called the Five Ways, or the Quinque Viae, are found at the beginning of the first part of his Summa Theologiae. All five of these ways he proposes as proofs from effect to cause, that is, as a posteriori demonstrations. I should note that I am using graphical aids throughout these lectures, and they're available to those taking the course for credit. The four steps that are involved in Aquinas' demonstrations are shown in figure 6.1. These are that 1. An observational datum exists. 2. This datum is an effect. 3. This effect demands a proper cause. And 4. Therefore, the proper cause exists. This datum St. Thomas exemplifies in 5 different ways, namely, A, as movement, B, causal efficacy, C, contingency, D, degrees of perfection, and E, order, all observable in the universe. These lead respectively to the following characterizations of the proper cause that terminates each of the 5 ways. 1. A first unmoved mover. 2. A first uncaused cause. 3. A necessary being. 4. A most perfect being. And 5. A supreme intelligence or supreme ordering principle. All of these are ways of characterizing God, and thus the proofs, both individually and collectively, conclude to the existence of God. In these 5 ways, the prima via, or first way, is the one based most directly on Aristotle's physics. That is, the proof for the existence of nature's first unmoved mover. This proof may be paraphrased as shown in figure 6.2. It is an evident fact that some things in the universe are in movement. But whatever is in movement is dependent on something extrinsic to itself. For nothing that moves can be the complete and adequate explanation of its own motion, and so it must be moved by another. But if the mover that moves the thing in motion is itself moved, then it is necessary that it be moved by another, and it in turn by another, and so on. In such a chain of moved movers actually moving, however, regress to infinity is impossible. For if the chain extend to infinity, then there would not be any first mover actually moving, and since none of the intermediate movers move except insofar as they are moved by the first mover, none of the other movers would move either. Therefore, it is necessary to come to some first mover that is moved by no other. This is the first unmoved mover, whom everyone understands to be God. Now that's essentially the proof for a first unmoved mover. This proof, as commonly understood by Thomas, involves essentially subordinate chains of movers and moveds, and concludes to the existence of a mover that itself does not undergo motion, and so is incorporeal and immaterial. St. Thomas exemplifies the key principle in this argument, namely, whatever is moved must be moved by another, with the case of fire heating wood. Fire, which is actually hot, causes wood, which is able to be hot, to become actually hot. The same thing, he argues, cannot be actually hot and potentially hot at the same time, though there's nothing to prevent its being actually cold and potentially hot. That explains why wood cannot heat itself, but requires an external mover and ultimately a first immaterial mover for its heating to occur. Observe that Aquinas does not use local motion for his example. Potency and act are easy enough to see in the case of heating, whereas these two concepts are somewhat difficult to identify in the case of local motion. Note that we have followed a similar procedure in previous lectures, where we have exemplified movement by heating rather than by local motion. Let us now return to the example of heating, for it offers us the opportunity to expand the application somewhat and show how it can provide an insight into subordinate chains of movers and moveds. Figure 6.3 shows the case we have previously treated: fire or flame in the process of actually heating water, which we have shown before as figure 4.3. Now we have extended the example, as shown on the right of the diagram, to consider also the air above the water that is being heated. In so doing, we now have a chain of movers and moveds, as illustrated on the left of the diagram. At the top, the fire heats. Action is in the agent. In the middle, the fire heats the water. Action is in the agent. Reception is in the recipient. But the heating, the motion we are analyzing, is not in the fire, but it is in the water. At the bottom, the water that is heated by the fire is in turn heating the air above the water. The fire is still an agent. The water is both a recipient and an agent, and the air is a recipient. The fire is a mover, the water is a moved mover, and the air is simply a moved, unless we wish to have it heating the thermometer or some other object. The point is that we cannot go to infinity in a series of moved movers, Without the fire, the water would not be heated, nor would the water be a heater, nor would the air be heated, nor would the air be a heater, and so on. In a series of movers, there must always be a first. The motor causality principle. At this point, I return to Aristotle's physics to examine an alternate proof of the motor causality principle. Whatever is moved by another. This is given in the 7th book of the Physics, and it is of interest because it specifically addresses the problem of causality in local motion. St. Thomas comments on this argument and evaluates it as a strict demonstration, indeed as a demonstration propter quid. Aristotle's proof is based on the divisibility of the continuum and may be paraphrased as shown in figure 6.4. The argument reads as follows. It seems obvious that everything in motion is necessarily moved by something. Yet there are cases where the source of the motion seems to be within the object moved, and thus the possibility arises that the object moves itself. If it can be shown, however, that the object stops when some other thing stops, this will count as evidence that the object is not moved primarily and essentially by itself, but is being moved by another thing. So let the object moved be a body AB, and since it is a body, it is divisible, so let it be divided at C. Now, assume that the part CB stops, and then the whole AB must stop also. If AB does not stop, then assume that it is in motion. In this case, if part CB continues at rest, it is possible that part AB be in motion. Should this be so, however, AB could not be in motion primarily and essentially, although it might be moved through a part or only accidentally. Since what is of concern here, however, is an object that is in motion primarily and essentially, in this respect it must be held that the whole AB stops when something else stops, namely its part CB. Therefore, it is being moved by another. And that's the end of the proof that St. Thomas gives in his commentary. The force of this proof is very difficult to grasp at first reading. You'll have to read it again and again and think about it. It involves what may be called the stopping thesis, namely that if a whole stops because a part stops, the whole must be moved by another. This thesis has been disputed, accepted by some, rejected by others, from Galen in the 2nd century all the way to Anthony Kenny in our own day. But Aquinas commented on this passage also and regarded the demonstration as a demonstration propter quid, as I've said, for, he writes, I quote, it contains the reason why it is impossible for a movable object to move itself. And the reason St. Thomas gives is cryptic. Again, we have another of these difficult texts. And I quote, there cannot be a movable object whose motion does not depend on its parts. Just as if I were to show that a divisible thing cannot be the first being, because the being of whatever is divisible depends on its parts. And thus, this conditional is true. If a part is not moved, the whole is not moved, just as this conditional is true. If a part is not, the whole is not. The end of the argument. Now, we do not have time to reflect on this argument at length. Suffice it to mention that its middle term is the quantitative divisibility of the movable object, and it is perfectly general. It applies not only to the fall of a heavy body and to projectile motion, but to the growth of a plant, the flight of a bird, and the explosion of a star in the depths of space. None of these divisible objects completely and primarily initiates its own motion, and thus each must be moved in some way on another. Since this particular proof makes use of divisibility, it can be put in quantitative terms, and this makes it easier for one to grasp why an infinite regress of moved movers is impossible. Assuming that the falling object must be moved by another, either the mover that moves it directly is itself unmoved, and hence immaterial, and this is the way Sir Isaac Newton thought gravitational motion should be understood, or the mover is moved locally by another. The second alternative here sets up the possibility of a regress to infinity. But this is impossible, for should one be able to go to infinity in movers that are moved locally, an infinite length would have to be moved in a finite time. To see this, all one need do is reflect on the facts: 1, that whatever is moved locally must be a body, and hence must be divisible, and 2, that an infinite number of such bodies is equivalent to a single body of infinite length, since movers cannot move unless they are either contiguous or continuous with the things moved. But it is impossible for an infinite length to be moved in a finite time, and thus it is impossible to regress to infinity in local motion. Therefore, at some point along the line, one must come to an immaterial mover and ultimately to a first unmoved mover when trying to explain any particular case of local motion. Validity in the present day. Anthony Kenny rejected St. Thomas's 5 ways because he thought they were too embedded in medieval cosmology to have any relevance in the present day. With regard to the medieval worldview, it is true that St. Thomas took the universe to be structured generally along the lines of Aristotle's On the Heavens, in Latin, the De Caelo. And if one attempts to instantiate the first way, as Kenny did, by tracing lines of causality from the terrestrial or sublunar region through a long series of internesting spheres to the primum mobile, or the outermost sphere, one is tempted to identify Thomas's God with Aristotle's primum mobens immobile, first unmoved mover, and locate him at the periphery of the universe. Not only Kenny, but many Thomists throughout history have followed precisely this line of thought. That is why they tend to exemplify Aquinas' idea of an essentially subordinated series of movers with mechanical linkages, any of which moves only because the previous one has moved it. This lends itself to convincing arguments, such as that behind the question, does lengthening the handle of a paintbrush, even to infinity, make it any more capable of painting by itself? But a difficulty is latent here that we must face. For Aristotle and St. Thomas, actions were transmitted from agent to recipient instantaneously, just as they thought that light from the sun illuminated the Earth's whole hemisphere in an instant. they were unaware of any time lapses that might be involved in impulses that are transmitted physically from one object to another or from one part of an object to another. Now we know that physical influences take time to travel, and this fact has important consequences for the proof from motion. If the essentially subordinated series of movers and moveds is likened to the fall of dominoes, the fall of the last domino will be temporarily quite distant from that of the first. And if one applies this line of thought to the prima via, one could interpret this to hold that the argument does not prove that God exists here and now. It proves only that he existed some time ago, perhaps a very long time ago, say at the Big Bang some 15 billion years into the distant past. Clearly, this is not what St. Thomas had in mind. As he understood his own arguments, God is not situated either at the spatial or at the temporal limit of the universe, but is present everywhere within it, wherever nature or humans act to initiate any causal action whatever. And that is why I prefer to formulate the prima via along the lines proposed by Aquinas in his Summa contra Gentiles, the Summa against the Gentiles, over that which is in his Summa Theologiae, his sum of theology. In the Contra Gentiles, St. Thomas explicitly sets up the regress in a series of alternatives. An object that is in local motion, say a falling body, is moved by a mover that either is unmoved or is moved by another. If unmoved, one has already reached the immaterial order. If moved, then its mover in turn either is unmoved or moved by another. If unmoved, one again has reached an immaterial mover. If moved, the two alternatives again present themselves. Note that at each point in this way of formulating the argument, the investigator is invited to entertain the possibility of God's direct presence in the local region. One need not postpone his action, either temporarily or locally, by removing it to the recesses of the universe. We might be tempted to such postponement if we entered immediately into the discussion of long series of moved movers, as the argument presented in the Summa Theologiae seems to invite us to do. Using techniques of this kind, by the way, we might be able to show that the Newtonian or classical mechanics presents no obstacle to understanding St. Thomas's prima via or his other proofs. But if Newton's antinomies against the prima via are thus dissolved, what about more recent science, as seen in quantum theory and theories of relativity? I would say that these are even more easily reconciled with Thomistic proofs for God's existence than is Newtonian science. But here, the philosophy of science that one embraces becomes critical in accepting or rejecting the reconciliation. The precise point is how to interpret such technical terms as force, field, potential, energy, and mass, to say nothing of compound terms such as mass energy, space-time, and wave particle. Through the use of such terms, I suspect that we have come to regard problems relating to local motion as already solved in such a way as no longer to require a motor causality principle. We are disposed to do this, I have come to think, because we absorb motor causality into such technical terms as these. And thus, we effectively terminate the argument before it can be started, and so insulate it from philosophical inquiry as to nullify its value as a starting point in any search for transcendence. The motor causality principle, whatever is in motion is moved by another, is particularly difficult for many people to accept when applied to local motion because they think that such an application has been invalidated by Newton's 3 laws of motion. And these are what we refer to as the Newtonian antinomies. But this is not the case. But because it is commonly believed to be so, I shall here examine in some detail how the principle may be applied to this type of movement, namely local motion. 3 instances of local motion. Let me illustrate the situation by taking object AB, a divisible body, and instantiating it in the different ways shown in figure 6.5. These are 3 in number. 1 as a block of wood, 2 as a mechanical mouse, and 3 as a live mouse. In each case, I am interested in the local motion of body AB, a translational motion from here to there. So to be clear on this, I'm taking AB to be understood as a block of wood, an extended block of wood, as a mechanical mouse, which is also extended, and a live mouse, which is also extended. One end is A, the other end is B. In the first case, the block of wood, though the simplest to visualize, turns out to be conceptually the most difficult. So I'll postpone that. I wish to explain the motor causality involved when the block of wood moves, and again in 3 different ways. A, when I push it, B, when I throw it, and C, when I allow it to fall to the ground. The other 2 cases, those of the mouse, whether mechanical or alive, are less difficult, because the mouse rather obviously moves itself, whereas the block of wood's claim to being a self-mover is not at all obvious. Let us therefore start with the mouse and inquire into how its motion can enlighten us on the principle everything in motion is moved by something. The live mouse may be regarded simply as a block of wood, AB, shown as made up of parts D, E, and F in figure 6.5a. Let F denominate the part or parts that seem to move as a whole, and D the quantitative parts that do the moving when the whole moves. I do not intend to enter into the physiology of mice, so I will be content to identify E as the brain, the heart, the muscle, and the legs, to all of which we ascribe the mouse's motor activity. Aside from these parts, however, Aristotelians will insist on yet another mover, D. Unlike the other 2 parts, D is not simply a quantitative part. It is a qualitative part, or more precisely, a power part, the motor power of an animal's natural form, which we modeled in our 4th lecture in figure 4.2. Now, another term for the mouse's natural form is soul, because Aristotle applied the soul to all living things, and though he spoke of plant souls, animal souls, as well as human souls. Now, to the extent that the soul, or natural form, is not a quantitative part, and to the extent that it is separable from the mouse's body, and upon separation results in a dead, or inert, or unmoved mouse, we can say in this instance that the soul is other than the mouse's body. Therefore, the body's movement illustrates the principle, whatever is in movement is moved by another thing. Now, for those who have difficulty with the soul concept, let us consider now the mechanical mouse, and for the sake of simplicity, let us conceive it too as merely a block of wood, AB, moved by wheels that are made to rotate by a coil spring or a stretched rubber band. This is now shown in figure 6.5b. Wind up this mechanical mouse, place it on a smooth surface, and it too seems to move itself. The case is not dissimilar to that of the live mouse, so let me label the moved part, the block of wood, F, and the moving part, the wheels, E. Perhaps I should include with the wheels the spring or the rubber band, for a further condition is needed for the wheels to move the block of wood. The spring must be coiled, or the rubber band must be stretched. And although the coiling and stretching may introduce a quantitative change in the object coiled or stretched, the resulting modification is more qualitative than it is quantitative. It is difficult to name this qualitative part, which I shall label D, but common usage will let me employ the terms force or energy. We say D moves E and E moves F, in the sense that the force moves the wheels and the wheels move the mouse. Or we say that the mechanical mouse moves as long as there is energy in the spring or in the rubber band, and this energy moves the wheels, which in turn move the mouse. Note how in this explanation, the concepts of force and energy play the same role as the concept of soul. If one were to inquire whether the case of the mechanical mouse instantiates the motor causality principle, we have to reply to the extent that the force and the energy are different from the body AB, to that extent whatever is in motion is moved by another thing. These cases have illustrative value, but it seems to me that neither is precisely what Aristotle had in mind when he spoke of a body, AB, moving primarily and essentially, for both can be traced down to motion through a part. And through a part, per partem in Latin, is usually opposed to primo et per se, in Latin, the Latin for primarily and essentially. The simple block of wood, however, unadorned with wheels, spring, or rubber band, can move primo and per se, so now let us turn our attention to the simple block shown in figure 9.5c. First, imagine this block AB on a plane surface, and let us examine the case where it moves because I push it. In such a case, there's no doubt that whatever is moved by another, and I am that other. Note here, however, that even I can be replaced by the force concept, for my push on the body can be conceived as a mechanical force, and then we say that the block of wood, F, is moved by me as a pusher or by a force, I/E. Second case. Instead of my merely pushing the block of wood along a surface, let me now throw it through the air, as shown in figure 6.5d. Consider the thrown block in simple translation motion, and then the whole block and each of its parts move with the same velocity. Now, does this case instantiate the motor causality principle? I threw the block. Let there be no doubt about that. And so it would seem that I am a mover. In a general way, that may suffice for an answer, but it does not seem to explain how I move the block after it has left my hand. Perhaps we should say that I impressed a force, or an impetus, or a momentum on the block of wood, and this serves to explain its motion. Note that, as in the case of the mechanical mouse, explainers such as these are essentially qualitative. So now let us say that the moved body F is moved remotely by me, I, now distant from F, but proximately by a qualitative part D that inheres in the block, which I conceive as force, energy, or momentum. Finally, let us consider the case where I do not throw the block of wood, but simply remove the support from under it, and it drops to the ground, as diagrammed in figure 6.5e. The block of wood moves, and clearly I do not move it in any essential way, and so again it seems to move itself. But is this actually the case? If we subscribe to the powers model of an inorganic substance we developed in the third lecture, the case is not very different from that of the live mouse. Like the mouse, the wood is a natural body, and it has the power of gravity as part of its nature, just as the live mouse has motor powers as part of its nature. I am the initiating efficient cause of the fall of the block, true, but once I have removed the support under the block is moved by its own nature, the nature of wood, through its power of gravity. So we would identify the elements involved in the body's fall as F, the moved quantitative part D, the moving qualitative part is power or force of gravity, and myself, I, the initiating mover, who activated a power inherent in the wood as part of its nature. Efficient and material causality. From this exercise, we can gain some idea of how difficult it is to trace causal agents behind local motion when we resort exclusively to the terminology of modern science. In such a circumstance, causal efficacy has to be interpreted through the concepts of force, energy, and momentum. Without such terminology, for example, in the way the proof for motion of an unmoved mover is stated in Aristotle's text or in Aquinas' commentary, we gain some appreciation for the sheer inertness and passivity of the material object as such. The introduction of force and mass energy in this context enables us to focus attention on elements of efficiency and activity in the material substrate. This focus also provides a ground for suspecting that elements of the divine may be found in matter. But when we absorb motor causality totally into these terms and regard them as logical constructs that have no reference to the real world apart from a theoretical system of which they form a part, the proof quickly loses its persuasive power. In effect, we suppress any intimation of transcendence that is to be found in the movement of material objects. And that is why, for many of our contemporaries, physical arguments for the existence of God terminate before they start, or they become so insulated from philosophical inquiry as to nullify their value as valid starting points. If we adopt a realist philosophy of science, on the other hand, and particularly if we restore causality to its proper ontological category, instead of seeing it as a psychological projection on reality, as do Hume and Kant, we can go far in making Aquinas' prima via intelligible to the modern mind. in my view, the primacy of local motion and the divisibility of the material continuum in the world of nature is the essential starting point for this type of argumentation. And that is also to see that in many proofs, material causality assumes equal importance with efficient causality. Arguments through a material cause, as in the way St. Thomas certifies the proof we sketched earlier of the stopping thesis, frequently yield conclusive results when efficient causes prove opaque to our investigation. And yet the action of efficient causes is discernible in the cases we have just discussed, despite their use of scientific terminology. Every change in the universe involves local motion, and as such has both inertial and gravitational components. Changes also involve thermal, electromagnetic, chemical, vital, and even psychic energies. When we abandon the so-called clockwork universe, there is less room for essentially subordinated series of movers and moves that work in mechanical fashion. But the same type of subordination is still to be found in the action of fields, and particularly vector fields, even though these imply reference to different kinds of forces and energies than those involved in classical mechanics. By way of example, using the space-time construct of general relativity, every natural or forced motion in the universe is determined by the energies involved in its production. Such motion requires continued specification and determination throughout every instant of its motion in a time-independent way, following the path of a geodesic to attain a predetermined goal. To see the full implications of this statement, I digress now on the relationship between God's causality and nature's causality as these bear on problems of local motion. This topic is addressed by St. Thomas himself in an objection he raises against his own proof for God's existence, to which I now turn. Aquinas' own objection. The article in the Summa Theologiae that explains the 5 ways is one of the longest articles in its first part. It is remarkable that St. Thomas raises only 2 short objections against this extensive line of argument, which is now a classic in Western thought. The first objection, undoubtedly the most difficult, is the problem of the existence of evil in the world. But no less easily dismissed is the second, which, beginning with a principle of parsimony similar to Occam's famous razor, reads as follows. And this is St. Thomas's objection. I quote, "Whatever can be effected by a few principles does not require more. But supposing that God does not exist, everything that goes on in the universe can be fully accounted for by alternate principles. For natural effects are explained by nature as a cause, and intended effects by human reason and will. Thus, there is no need to suppose that God exists." Now, that's Aquinas' statement, and notice it's an objection he presents against his own teaching. So, setting aside that second alternate principle involved in the problem of evil, we must focus on the first, the alternatives posed by nature. If the fall of a heavy object or the flight of a bird is caused by nature, what need is there for God's causality to explain their respective motions? St. Thomas solves the problem in his reply to the objection, but his solution is too brief to be of much help. He writes simply, and I quote, "Since nature acts for a definite goal under the direction of a higher agent, things done by nature must also be referred to God as to a first cause." Close quote. That's it. That is all St. Thomas says. Both nature and God are required to explain the fall of the body and the flight of the bird. But exactly how they are required and how they respectively influence those motions, he leaves us to puzzle out for ourselves. Fortunately for us, St. Thomas does return to this problem toward the end of the first part of the Summa. This is in question 105, Article 5, where he is explaining his teaching on the divine concourses, or how God himself is active in every agent cause. The Latin for this is Deus operatur in omne operante, which reads literally, God operates in everything operating. Aquinas first distinguishes the four kinds of cause, as we have done in our discussion of the causality of nature. And then he goes on to explain God's action in each, the material cause alone accepted. For our purposes, it may suffice to concentrate only on formal causality, for that is what is involved in nature and gravity and impetus, all of which are forms that initiate the motions we have been discussing. Of such formal causality, what Aquinas writes is shown in figure 6.6. Now I put that in the figure, but it's a text which I read as follows. Consider that God moves things to operation not only by applying their forms and powers to work in the way a craftsman applies the axe to cutting, without giving the axe its form, he also gives these forms to created agents and conserves them in being. Thus, he is not only the cause of action by way of giving the form that is the principle from which the action proceeds, the way in which the generator is said to be the cause of the movements of heavy and light bodies. He is also the cause as one who conserves these various forms and powers in being, just as the sun is the cause of colors appearing, in that it gives and maintains the light by which they are seen. And having explained this, St. Thomas then goes on, and again I quote, it further follows that God acts interiorly in all things, because the form of anything is within it, and the more so, the more basic and universal the form is. For all things, God is properly the universal cause of esse, or being, and esse, which is Latin for is innermost in all things. This is the reason why in Holy Scripture the operations of nature are attributed to God as to one operating within nature itself. So much for the quotation from St. Thomas. This, then, is how Aquinas sees nature as functioning causally, but doing so as God's instrument. Matter itself is sluggish and inert. The falling body, precisely as a body, and thus divisible into quantitative parts, is radically incapable of moving itself simply in virtue of those parts. The heavy body falls not because it is a body, but because it has the nature it has, and because that nature is endowed with characteristic forms and powers through which it is able to initiate activities proper to that nature. More specifically, it falls because there is within it the form or power of gravity, because this form or power is sustained in being by subsistent being itself, and because it is activated by secondary causes that themselves act in virtue of the first uncaused cause. Nature causes the body's fall, so there is truly a causality of nature, but God's concourses, running along with, is there with nature and its powers, sustaining them in being, energizing them them, we might say, and enabling them to bring about the effects we attribute to them in everyday life. Let me return now to the scientific context which we were treating before digressing on these passages in the Summa Theologiae. Obviously, the principle, whatever is moved by another, allows for a variety of interpretation. In the Greek medieval framework, the phrase by another was understood to be effected through some type of contact, either mechanical or virtual, whereby the mover exerted a direct influence on the thing moved. In a Newtonian or Einsteinian framework, the same phrase is understood in a spatio-temporal or metrical way. It is then frequently interpreted as the action of some type of field or potential that is able to determine precisely the resulting motion. In either framework, the existential character of motion ultimately requires that the moving object and its powers be sustained throughout. That is, in the object's coming to be no less than in its being or esse at every moment of its existence. Here, the essential dependence of any existent on subsistent being itself, whether transitory as in the case of a motion, or stable as in the case of an object, cannot be dispensed with. The problem of the scientist is that of discerning the secondary causes, the detailed processes through which this existential influence is channeled in the daily workings of nature. For St. Thomas Aquinas, there is an intimate link between the causality of God and the causality of nature. Aristotle's first mover may be located at the periphery of the ultimate sphere, but Aquinas' God certainly is not. He is everywhere, by his power and his presence, no less in the remote depths of space than in the microstructure of matter. Man has his artifacts, and in the technological age in which we live, we all rejoice in the remarkable feats of intelligence he can perform through their use. In Aquinas' view, God stands in relation to nature, much in the way that man stands in relation to his artifacts. Simply put, nature is God's artifact. And once we understand that, it should not be too difficult to see how God serves as an ultimate explanation in our expanding universe, as well as, if not better than, he did in the circumscribed universe of antiquity and the Middle Ages. Nature's first unmoved mover. Finally, we return to our philosophy of nature for a final reflection on nature's first unmoved mover. In natural philosophy, the first cause of motion is considered only insofar as it is necessary to understand motion in natural things and to determine whether the primary source of motion is or is not a natural body. A body is something extended and divisible in parts that are in it and thus compose the whole. A body or extended whole is not an independent being, but depends on its parts for its being. A body is dependent also upon its parts for being moved, because motion requires a subject that is extended and divisible into parts. But the first cause of motion is completely independent in action, and hence also in being, because operation follows being, and the manner of acting is consequent upon the manner of being. Therefore, the first cause is not a body, and does not have parts on which it depends for its being and acting. It is not composed of matter and form, nor of potency and act. It is not capable of being moved or having motion, either by itself or by something else, but it is the unmoved mover of other things. Because it is unmoved, it is not a temporal being, but is eternal. Because it is unmoved and incorporeal, it does not cause motion mechanically, as one body moves another from without, but rather as mind or intelligence moves a body with a higher order of action. It is the proper business of the natural philosopher to seek the causes of motion in natural bodies. In order to understand his subject, he must not rest content with some intermediate mover, nor with all intermediate movers, supposing that they could all be determined, but must seek the first cause of motion. Finally, and this is the most important, it is only after one knows through the study of nature that there exists a kind of being that is not mobile or corporeal, but is immobile and incorporeal, that one can show the need for a science beyond the philosophy of nature, the science of metaphysics. After we have covered the physica, as the Greeks might say, we have opened the possibility, we opened the path to a possible metaphysica, the Greek for a science beyond physics. But to pursue that path would take us far beyond the modest undertaking in which we have been engaged throughout these lectures, the philosophical study of the world of nature.